What if you tried to fly using fire extinguishers? It sounds like something a 12-year-old would ask. It is, but it's also, technically, not completely wrong. A fire extinguisher pushes gas out with force. Every action has an equal and opposite reaction. Point two extinguishers downward, pull the handles, and Newton's third law says you should go up. For about 8 seconds, you will. A standard CO2 extinguisher produces roughly 50 newtons of thrust. To put that in terms you can feel, it's approximately the force of a golden retriever sitting on your chest. To lift a 70-kilogram human, you need around 700 newtons upward. That's 14 extinguishers firing simultaneously. Great, strap on 14 extinguishers. Except each full steel tank weighs about 14 kilograms. That's nearly 200 kilograms of hardware. You've just added 3 of yourself to the problem. Now you need more thrust to lift those, which means more extinguishers, which weigh more, which need more extinguishers. Rocket scientists call this the tyranny of the rocket equation. You can also call it the reason this doesn't work. It's the same math that humbles aerospace engineers with billion-dollar budgets. Your wrists never stood a chance. And before you ask, yes, someone has actually tried this. The result was exactly as undignified as you're imagining. At a certain point, you're not a person trying to fly. You're a very motivated shopping cart. But let's say you solve it, magically. You generate the thrust, you leave the ground. Now the real problem starts. Rockets stay upright using gyroscopes and computer-controlled nozzles making thousands of microcorrections per second. You have wrists. Human, shaky, coffee-affected wrists. Even a 1-degree tilt sends thrust sideways instead of down. That sideways force becomes rotation. Rotation compounds. You start spinning. You try to correct. You spin faster. There's no software to save you, just physics doing exactly what you asked in a direction you didn't intend. You are now a human ceiling fan, pressurized, airborne, and screaming. And then, 8 seconds after it all began, the tank's empty. No glide, no parachute, no soft landing. Just gravity, patient and indifferent, taking back what it briefly lent you. Here's the strange part. The physics isn't wrong. Newton's third law is what launched the Saturn V. It's what keeps the ISS in orbit. It works at any scale, even a fire extinguisher. The difference isn't the idea, it's everything around it. Stability, power, precision, duration. You have none of those. But for 8 seconds, that gap between the physics being right and everything else going catastrophically wrong, the same equation that put humans on the moon is running through your hands. And somehow, that's exactly what makes it worth thinking about.